Welcome back. So exciting. I've started working with the Arduino, programming it. Now it's ages since I've used an Arduino, so obviously my befuddled brain, I'm having to remember everything. First thing I thought I'd do, not focusing, is to get an LED flickering. Always a good start, just to convince myself that I do know what I'm doing. This is the LED that indicates whether the alarm is set or not. Just wanted to start somewhere. One thing to note is when you first get a Mega, before it's programmed or anything with a sketch, all the inputs outputs on the Arduino initially set to input, so you can't theoretically damage it. Obviously you don't want to feed a huge voltage into it, but with this situation, because I'm running only power is through the USB to this, I've connected a common ground, which is fine, to everything else, but I haven't got any power coming out of this to run anything else yet. I'll explain why later or something or other. Anyway, I'll just connect that up, and I've got a 220 ohm resistor, and I wanted to check what current it was because the output pins a maximum of 20 milliamps, absolute maximum, and this is hovering around 10 milliamps, so that's well within the safety margin, so that's fine, which is good. Check that, my confidence is growing. And here's the very complicated sketch so far. Let me see if I manually focus to stop the moire. Oh well. Set up, pinMode 7 to output. Loop, keep switching it to high. That's very, very clever. Clever stuff. Hence the fact that is flickering. Right, let's do something a little bit more complicated now. This is all very nice. I've remembered how to write a function. I think the way I'm going to do this is to slowly work through all my features and things I want to inputs and outputs and just write a function for each one. So there's basically simply digital write pin 7 to high, whereas this is a little function void because it's not returning any sort of information. I'm going to call it alarm set. Boolean, the input is state, it's just a variable called state, which is a boolean, and then digital write 7 with state. So I can now send alarm set either high or low. Okay, I'm not going to keep doing this, but just as an introduction, so I've set the pinMode pin 7 to output. I've created a global variable called on/off, and I've set it to low. Again, it's boolean, so it's got two states. Here's the loop where you put all the things, all the software, or all the code that you want to repeat. It goes round and round. It says basically make on/off equal to not on/off, which means that it just sets it to whatever it isn't. Then there's my function call, alarm set on/off variable. So that's going to be high, low, and then delay half a second. And sure enough, it's calling my function, and the overall effect is that. So that's nice. As I say, I'm trying to remember all this stuff. It's all coming, I wouldn't say flooding back, trickling back. So that's okay, but that's very satisfying. I do apologise for sounding all nasally and bunged up. My children went back to school for the week before Easter holidays, which is 2.5 weeks ago, and they brought a cold home with them. Despite all, well, thankfully not COVID, thankfully, but it shows you despite all the precautions the school's taking, they still brought a cold home, and we have been sharing it and passing it around us within the family for the last 2.5 weeks. Oh, what joy. So I do apologise for being all bunged up, but hopefully before too long it will go. Next step, get the time zone indicating LEDs, the flickering ones, working with another slightly more complicated function. So this time I've added outputs 9, 10, 11 and 12 that connect to each of those LEDs. I've also remembered to make a note if you have double slash or whatever you call it. Sounds unpleasant. It means that the code ignores it and you can write comments to yourself, and I always make a note of those. This time here's the loop, and I've got it to count up using a for loop, using a for function. Byte b, because it doesn't have to go up above 16, equals 0, while b is smaller than 5, B++. So it goes round and round and round, from starting with 0, adding 1 each time, and when it gets bigger than 5, it goes back to the start again. Then I've got a new function called time zone LED set. We're passing it B, the value of B, and then a delay of ½ a second. And then I've got the function, which is, I'm only going to go over this. I won't keep going on like this, but it might be interesting to some people, and also to others who can tell me how badly I'm writing this. Void, not returning anything. Time zone LED set. Byte zone, that's what we're passing to it. It always starts off, because I only want one of these time zones on at a time, so it starts off by switching them all off, and then simply, if zone is 1, then switch that on, and etc, etc. It means if I pass it a different number, like 0 or 5, it'll switch them all off for some reason, I don't know, but it's quite useful. So that's what's happening. There will be all sorts of very clever ways of doing this with one line of code, but just for my own peace of mind, my brain is a muscle that needs quite a lot of exercise, I'm going to keep it really simple and clear. I've learnt so many times that by overcomplicating one thing, before you've got everything laid out, it just makes it really difficult. So I'm keeping it simple. Simple is good. Look at that. Logarithmic fading of the dial illumination. And this is why I ended up doing it like I did, because it does look so nice. Like that, it's just brilliant. And as an interesting aside, you can see the pulse width modulation with this camera having a high camera speed. You can see the horizontal lines flickering. If that was a problem, I could change the pulse width modulation clock speed using a bit of code on the Arduino, but my eyes can't see that, so it's not a problem, as I'm not planning to video this for hours on end. But it just looks so nice. So when it's bedtime and Erin switches it to sleep, in effect, it'll just fade down beautifully, and then when she switches it back on in the morning, it'll fade up beautifully. It's so nice. It's the function I wrote when I was doing the Is It Time for Tea machine. No, it wasn't. Barometric Prognosticator 2. I had so many different things. I had the moonlight and the sunlight and the this and that. Loads of different things that I needed, sets of lights that I needed to be able to fade up and down, remember where they were, and could change individual ones or all of them at the same time. Hence the fact that this code, I've reused it lots of times because it works. I'm sure it's not pretty, but it does the job. Ooh, parcel has arrived. Very good. I only ordered it on Sunday afternoon and it's now Tuesday lunchtime. Oh, it's a Polish brass visitor's bell push. Look at that. I've ordered this for someone who's bought one of the Heraldic Clarion Door Horns. It's the second time actually, because originally I bought one of these for an American customer who wanted to have the doorbell button as well as the rest of it supplied. That is so nice. Proper ceramic as well. Brass casting and a good quality switch. Oh, look at that. That, which is the Heraldic Clarion Door Horns. How exciting. Replace a boring old ding-dong or ringing bell with your very own beautiful, beautiful air-powered Steampunk door horn, not doorbell. It actually uses an electric air pump inside. It's got batteries inside it to run a proper working horn. There you go, you can see there's a little battery holder in the back. And it comes with the required, your desired amount of this beautiful braided, it looks like copper but it's actually braided rayon, metallic. It just looks lovely, beautiful. Length of wire. It's also supplied with the relevant number of these lovely little cable clips. You know, why hide a piece of wire? This is the Victorian. They were so fascinated and proud of their technological achievements, they wouldn't hide things away. They proudly display it, and that's the wooden junction box that connects the end of the copper cable to your existing piece of bell wire or whatever. How lovely. I've just discovered something interesting. I think this is worth pointing out. I never realised. light emitting diodes are diodes that only allow electricity to pass one way. And I'd got the 4 time zone diodes connected up like this. 4 different outputs from the Arduino with a common resistor, current limiting resistor. What I found is this doesn't have any effect at all. I can even remove that from the circuit and these will still work at full power, because what I've realised is happening, the electricity, so I'm feeding this one, the electricity comes in here and then can, because these ones are all low, set to low, they're not floating on the Arduino, so they're at 0 volts, the electricity can then sort of creep through silently through all these other ones to get back to 0 volts, so this one is lit really brightly. What a pain! Interesting for future reference. Don't know whether it applies to all flickering LEDs, but certainly to these ones. So what I'm going to have to do is to put a bigger resistor on each of these ones, a 4K7, 4 separate ones. Isn't that strange? That would be the easiest way to solve it. So, about half an hour later, loads of fiddling about. What started off as a cunning way to save time, effort and components has turned into a cunning way to use up more components, time and effort than I would have thought would be possible. But as you can see now, there's the one on the back illuminates. Hang on a minute. A bit more salubriousness required. There's the one on the back that I can look into without burning me retinas. And now, that's better. Hang on a minute. That's it. Oh, that's much better. I can actually, it's quite clear as to which is indicating at the time, except for the third one, which doesn't seem to want to work. Oh joy, unbounded. Well, 3 out of 4 is not bad, but you can actually look at them, which is nice. Back to the drawing board. Would you Adam and Eve it? Looks like that LED is faulty. How ridiculous. So, rather than, I mean, it's going to be like threading something through the eye of a camel or whatever it's called. I'm never going to be able to do that from here, so I'm going to have to take the whole lot to pieces again. I think it actually is 6 screws. Do you remember me saying about catch-22, getting everything so that you can take it to pieces again? Well, I've undone all that and then I remembered that I'd soldered all these on. So I've had to remove it by prising it out, having unsoldered it with my wonderful antique, well not antique, but very old solder sucker. They're brilliant. I've tried the desoldering braid, but this always works. It always does it for me. Squeeze that down, heat up the solder joint you wish to remove with this Teflon end thing. You put the schnozzle over the hot solder joint and press the button, and it does that, and it really works brilliantly. I managed to unsolder that LED, as you can see, with a couple of pops of that, so that's great. Now I've tested the LED and sure enough I'm very relieved that it doesn't work. I've now lost the LED anyway. Take my word for it, there it is. Useless, doesn't work. First time it's happened to me, but don't know why. So I've got another one which I'll now try and wriggle in from the back. I think I might have to use a 1mm drill and drill through these just to make sure I can clearly get the prongs through. What a pain. Finally, it's back together and working. Lovely, and now they're dim enough that you can look at them. That looks much better. Obviously, they're not going to normally cycle through that quickly, but it just they look lovely now. I'm very pleased with that. Next job, I've got those flashing things, is to sort out the encoder. Now, another fabulous thing about the Arduino was a number of libraries that very nice people have written to help you achieve things. It needs to take account, as I mentioned before, interrupts, so that the Arduino doesn't miss any turns as you make them, even if it's doing other things. It's just all quadrature and all sorts of other bits and pieces to do with how the encoder works, which of these gets a pulse just before the other one as you turn it, and how many pulses it gets. So I have used the encoder library before, but it was a long time ago and I couldn't remember how to do it. So basically, this is what's so great. I knew I had it installed, so you just go to File, Examples. These all come with every library that you load. Now somewhere, encoder. You say, okay, I want the basic example. There are other examples for other things. and there it is, it loads it. And then all I've done is to change the 2 pins. You know, it's fabulous. It's so clear, the descriptions. It is absolutely fantastic. This also uses in the example, and also the other thing I love about these examples, none of them are written by people who can't help but try and overcomplicate to demonstrate how fabulous they are. They're all written by incredibly intelligent people who understand the concept of making things simple so that people can then engage with them. This has just enough information to get this working, then I can leap on it and get it to do what I want to do. It's brilliant, and I say that as someone who used to be a teacher who expounded such things. So with this one set up, serial begin, 9600 baud, that means that this sketch, when I load it, will be able to the sketch will be able to communicate back to this laptop, to the IDE, and display stuff. It's going to print a line, basic encoder test, then it's going to cycle through, that's including the library there, the sketch including the library, then you just tell it which pins are connected to your encoder, and then you can read the encoder position. And I'll show you that. So if I've uploaded it, so if I click on the serial monitor, here we are, basic encoder test, and then as I turn it, I'll show you. Look, instantly I can go back down and it will go into the negative, back up. How many clicks, the position, it is just fantastic. And the Arduino can be running all sorts of other things at the same time, and because of the interrupts, and both the connections on this have got their own interrupt, it doesn't miss a trick. Isn't that lovely? Right, and that's how you can get Sketch to write stuff to the screen, which is very useful, especially in my case when I'm trying to debug absolutely everything I've written. Fantastic. I feel the next thing is another input device. So there's the first, the encoder. This one is going to be fixed to that long arm that sticks out. So it's got 5 different positions, different functions. Things like I want to set the time, I want to go to sleep, I want it to run as normal, things like that. And if you remember back to probably the last video now, a rotary switch, and I've wired it up with a potential divider across it. So one side's 0 volts, the other side's 5 volts, and there's the switch that wipes between the two. So that's 5 volts, that's middle one's 2.5, that one's 1.25, that one's 0 volts. And what we're going to do this time is we're going to use an analog input. We haven't used one of them yet. With the Mega, all these. What an amazing number of analog inputs. And that, again, great thing about the Arduino, you can set these to act as digital ins and outs or analog inputs. It's absolutely fabulous. I've used a analog 0 for mine. Here we are, 5 position control switch. So let's have a look at that and get something written to read what voltage it's sending back. Right, I've got it sorted out. I've set this just as a reminder again. 5 position function switch, pin mode. Now with the normal digital pins, which are all, I haven't focused it properly, all the green ones, you just use the first number, so D8 you just put 8, whereas with the analog pins you put A before it, not analog. So there we are, pin mode A0, input, note to myself, note to self. Then all I've done, so you can see I'm commenting out all the previous bits just as a reference. So serial, which print lines, that's going to print to the serial display on the laptop. Analog read A0, and then wait 100 milliseconds, 0.1 of a second. So let's try it. And I forgot to mention before, over this side of the screen, little magnifying glass. If you click on that, it opens up the serial window, and there we have it. If I switch it, that's at 5 volts. There we are, 757-ish. That's the next step. Then we go down to 500 and something or other. Then at 250-ish. and then 0. Isn't that fantastic? So it can work out with one wire from the switch which position the switch is at. Now I need to write something to turn these numbers that it's receiving into one of 5 outputs. So what I did, there are the numbers that were being outputted by the analog input, and what I've done is find the halfway mark between each one. So what I can say is, okay, if the signal that you're receiving is over 125, do that. If it's over that, do that. Then I've written a little simple function. This time, unlike previous ones, you can just see there, as void, it's not sending anything back, but it's receiving something. This time, it's sending something back, and it's not being given anything. Integer value, just call it an arbitrary name, analog read a 0. So it's creating an integer called value and reading that, the analog input. Then I've started at the top actually, so if val is greater than that, return 5. Return simply means stop running this function and leave it, and return in this byte, as a byte variable, return 5. If not, if value is greater than that, then do that. If value is greater there, so it runs down, otherwise return 1. So it then returns between 1 and 5, so it's turning all the analog voltages or readings into the simple 1 to 5 that I could then use elsewhere. If functions are absolutely amazing, I mean that doesn't even begin to say anything, but there are lots of different ways of arranging them, and this, if you're going to use return, you don't have to use if else, because if it finds it's right, it then leaves it and doesn't bother going through the rest of them, so it's quite efficient. And then what I've done is, and this demonstrates how to write a function into some other function. Where are we? Here we are. I've said serial print to that screen we looked at earlier. Read function switch, that's the name of the function with brackets afterwards without sending it anything. It then sees that, does that, gets the number back and prints it. So if we go to the serial display, there you go, it's 1. If I click the switch round, 2, 3, 4 or 5. I know it's basic stuff, but it's just something so magical about it. I mean, growing up with ZX Spectrums, ZX81 actually, and then discrete components doing all sorts of other stuff where you have separate integrated circuits with logic getting so many things achieved in a huge complicated fashion. This is just so much fun. I could sit here all day switching this up and down, but I won't. I'll get on with the next thing, and I think the next thing is going to be a motor working. That's very exciting. As I've mentioned, we've got the hour hand that goes from 0, for some reason, I've realised I don't need 0, but never mind. It's another nice little quirky thing of a steampunk invention, round to 12. It's not going to move between them, it's going to jump. So it just says each hour, and then you read the minutes off this dial. Now the hour display has a micro switch, which I've mentioned in the past, so that the final time, to make sure it doesn't lose track and the Arduino forgets where it is, every time it points to 12, it doesn't count degrees, it just says, okay, I need to reach 12, keep going round clockwise until I hit the switch. Now I'm not going to do that, use this one while I work out the stepper motor control, because I don't want to ram it into the switch and wreak havoc. I'm going to use the minute hand, because this can obviously go right round and in both directions, doesn't matter. So there's less likelihood of damaging things whilst I get it all wrong. And this one tells the Arduino where it is, calibrate, that's the word, using the reed switch and a magnet. So every time it goes round, and I don't know where it is yet, but the nice thing about this is I can set this hand. So once I've established where, or driven it to, in effect, when it finds the reed switch, I can then set this so it's 12, just for my simple human mind to be able to cope with it. It's far easier to think. I mean, the Arduino doesn't mind where it is, but just for my peace of mind, if I think, okay, 12 is going to be where it switches the reed switch on, that'll make a lot more sense. So I'm going to try and get this one working. So here's the back of it. There's the beautiful little stepper motor, beautifully geared down, really quite powerful with lots of torque. This one's connected to this interface board, which, as I said before, comes with these motors when you order them, with 4 LEDs, which are brilliant because you can see whether they're switching on and off, and if there's a problem you can then help to identify it. Now I need to set which wires or which outputs from the Arduino control this one, just to get it going round and round. I'm going to use a library. So it is a library called Excel Stepper. You can go to Sketch and include library. There's a feature here called Add Zip Library, and then you can point this. If you click on this, I've already got it installed so I don't need to, but if you click on that and then navigate to the folder, the zipped folder, click on that and it will install that and give you all the features, the examples, everything. It is just so fabulous. So now I've got that, what I can do with this sketch is to say, okay, Excel Stepper, click on that, and look, as if by magic, it's added the reference to the acceleration stepper, which is fantastic. So now I can use that within this sketch. And look, our first moving part. This is just moving to 4 different positions. It just shows you that once you've got the library installed and you've written a little bit of code, which I'll show you in a minute, you can tell it which position you want it to go to, and it will go there. See what I mean with these useful LEDs? Because if it didn't work, I could then see whether any of these were actually switching on and off or in order. It would just make it much easier to diagnose a problem. See how fast it gets when it's full speed. Full speed. Right, there's the code. So you include, or you tell it to include, ask it to, the acceleration stepper library. Then you define an object, and I apologise if that isn't the right nomenclature, but I've called this minute stepper. I've said there's 8 steps because unlike lots of stepper motors, these little ones don't have 4, well they do have 4 coils, but they don't pull it round with 4 movements, 4 rotational points each rotation. They actually have 8 because they switch 2 magnets on at the 2 electromagnets on at the same time, so it turns it into 8 separate movements per rotation. And the other thing to watch out for with these little motors, these stepper motors, is you need to swap over the 2 middle numbers, the 2 middle pins, otherwise it doesn't work. Can't remember why that is, but that's what you do. So there are the 4 connection, the outputs from the Arduino, but the 2 middle ones are swapped. Then, moving on, you can define the maximum speed. I've set it to 400 because it seemed to be okay. Not quite sure, and I can't remember what that refers to. I can't. I'm not even a hazard a guess. Plead ignorance. That's the best sort of defence. And the acceleration. I just experiment with these 2 and see what happens. These small stepper motors won't really move further or faster than 12 RPM because they can't keep up. But, you know, it looks about right now. And that's in setup, by the way. All I've set it to do, minute stepper, run to new position, 0, then to 2000, 500, 250. And it'll keep going round and round because that's in the loop on the sketch, so that it'll just keep repeating those things. And because of the way the run to new position, it just does that and ignores everything else. So, dear friends, my battery is about to run flat. Welcome back, sort of. It's the next day, but I've decided to split this video into lots of little short parts, addressable with links to particular time codes. I thought I'd go on a little bit about it. You can see I've got this working now, and I'll explain how and why. What it's going to do is going to find the 0, the read switch, and then stop. Look at that. And it's even going to know whether it's already sitting over the reed switch, because remember that reed switches don't have a specific on and off point. They're sort of vaguely, as the magnet comes close they switch on, as it goes away they switch off at some point. So it's very important to consider things like that. What happens is if this starts off with it just slightly, say 5 past, and it's still over the reed switch, if you don't take consideration of that, it'll just say, oh, I'm okay, I'm in the right place, and then carry on. But obviously it's not, it's cheating. So I'll show you how I did it. By the way, let's just watch it operating, because you can see these 4 LEDs. It's just uploading it, because it's the easiest way of getting it to redo it. You can see the acceleration speeding up, then it's going to move off that center reed switch because it was over it. Now it's going to keep going, and you'll see it suddenly stop this time when it reaches the reed switch again. Look at that, perfect. Now, so I've called it calibrate minute stepper. Seemed like a good idea at the time. It's not being sent anything, it's not returning anything, it just gets called and does something. What it does, it basically, with the acceleration stepper library, I realised that it will always leave one of the coils on, one of the outputs on, even when it's stopped. So to stop it doing that, I disable the outputs once I've finished working on it, and then that switches all of the LEDs off, just simply because I don't want one of the coils on the stepper motor being on all the time. Right, so enable output, so it allows the Arduino to speak to the interface. If digital read 36, now that's the reed switch. If it's low, which means that it is over the magnet, or the magnet's over it, then it says minute stepper run to new position -100, which I haven't worked out the exact details of a -800, but it means it moves clockwise far enough away to be no way to still be over the magnet. But it only does that if it starts off being over the magnet. If it isn't over the magnet, it ignores all that and just jumps onto this bit. So this bit then says set current position to 0, because, and I vaguely remember why I did that, but it basically the way it works, I'm sure it's very useful and I'll realise later on. But anyway, it does that. Minute stepper move to -10,000, which is huge distance, far larger than it needs to be, but I don't care. I want to make sure it actually does manage to do a full rotation. Now this is slightly different. This in effect is doing this sort of thing, run to new position, but not at the expense of everything else. It will keep checking, because if you look at this, move to -10,000, and we've got a do while loop here. So do this minute stepper run. Every time you run it, it then takes one more step, and then while, again, digital read switch is high, so it's the magnet isn't over it. So while the magnet isn't over it, it'll keep cycling around really fast and keep it turning. But as soon as the magnet reaches the read switch and this goes low, then it'll jump out of that and stop it. That's why it doesn't decelerate, it just suddenly stops it. Really useful, that. And the other thing is, because it stops between each of the movements, you've got a chance to have something checking what's going on, whereas with this one you can't interfere with it. It is going to do that until it gets there. So that's the purpose of that, and that's very useful, being able to do it like this. Then minute stepper set current position, so we now know that is properly 0. Can't remember why I did that. I think because I know I wanted it to move -10,000, and it might have thought it was somewhere else. So it sets it to 0, so that's the reference point. And then minute stepper disable outputs to switch them all off. That's it. It's finished now, until I want to move the minute hand. So that's, as I say, calibrate minute stepper. Now one other thing, digital read 36 is low. I should mention, in the setup, where is it, 36, here we are, 36. Another thing you can set with inputs is input pull-up. It's ever so clever, it really is. An input pull-up connects something like an internal 10k resistor between the input and positive. So it's not floating. They're very, very sensitive, these inputs. Bring your finger close to them or whatever can set them off and make them behave in odd ways. So without a resistor, this is what you have in effect. So while that is open, that switch, this is free to float all over the place and respond to radio waves, interference, fingers crossed, by anything. So you need some way of clamping it. So what you do inside the Arduino is in effect controlled by software. I'm overcomplicating everything now. Plus 5 volts. Inside there is something like, I think 10k, it varies a bit between different models. So that means when this switch is open, this is always at 5 volts. And you have to switch that on, and that pulls that right down to 0 volts. So that's what input pull-up means. Forget coffee, I'm on Lemsip and Strepsils. It's ridiculous. I wish I could get shot of this cold. Crazy. Anyway, here is the function for the hour. It's exactly the same as the one for the minute, except I realised that I'd wired the switch the other way around, so that's only the highs and lows are swapped. Right, dear friends, the moment of truth. Is this going to smash it to pieces and grind to a halt? I don't know, hang on a minute. Where's my pointer? There we are, let's upload it. The other thing it does, you've got one here that verifies it. If you click on this one to upload, it verifies and then uploads it. And it will point out errors, stupid things and mistakes and other bits to check if it finds any. Terribly, terribly clever. Right, what's it going to do? What have I forgotten? Actually, oh, no, I've just realised what I've forgotten, which is I have no idea where this hand should be. So, unscrew these. Oh, that means I have to unscrew that, which well, if I remember that that's at yes, okay, give me a moment. Oh, so it's going to move back a bit because the micro switch has clicked. Then it's going to go forward until it clicks and stops. Now I can set that to be pointing to 12. Now, I think the last part of this video, that heaven only knows is how long, but like I say, I realised after I'd done a few of these connecting bits that it would make a really useful video where people could think, oh, how do you connect an LED to one, or how do you connect a stepper motor, and then just to jump to that part in it, that chapter if you like. So, last bit is the real-time clock. As I said, I haven't used this type of real-time clock before. This is the one that is really accurate and has temperature compensation built into the chip along with the crystal. So it's very, very accurate. I haven't put the coin cell in yet. First thing is to install the library. It is actually RTC lib. So click on that. Right, so I'll include RTC lib. Well, here's the example. Let's just see what it does. Let's upload it. Oh, have I got? No, I've got nothing to connect or anything actually, because it uses the I2C connection protocol communication thing. The other great thing about the I2C, which is SCL and SDA, is that you can, each device you connect to it, you know, there's loads of different devices connected to the same 2 wires, and each one has a separate, a different address. It's such a fantastic thing. Right, let's upload this and see. Click on serial monitor. Ah, that's better. Here we are. Some intelligent looking times and dates. So that's great, because that shows me that the communications are working, and it's showing me all sorts of other clever stuff which I haven't bothered to read yet. It's telling me how many seconds have elapsed since the birth of computing, which was I think 1st of January midnight, 1st of January 1970. But the amazing thing is that the little chip here, the real-time clock, is keeping track of the time. I'm about to put the battery in it as well, the backup one. The Arduino is regularly communicating with it through these 2 wires, and then at the moment the Arduino is sending back through the USB wire to the serial display the time that it's read from that. So actually an awful lot is going on. It's very easy to forget in this day and age how amazing things like this are. I'll go and find the coin cell. Nothing but the best for Erin the truck driver. No affiliation obviously with all these things. Oh, it is baby and child proof. Give me a moment. It's made to take a while. Ha! It's not baby proof if a baby has a scalpel. Right, there's the battery and it says plus on the top. I'll film this, why not? Get grease off my fingers. Plus is at the top. I'm going to put that there. Yeah, and do that. There you go. Isn't that amazing? So now we can test this, because we'll switch off the power to everything and then switch back on and see what it says. Because that little battery apparently lasts up to sort of 5 to 7 years. Whether this is switched on or off or whatever, longer I assume if it's connected to a power supply. Isn't that amazing? So it just keeps the day, date, year, month, time, all counting away quite accurately to itself, that can be read, referred to by the Arduino whenever it needs to. And also the good thing is, you can set the real-time clock using this function, so you can just put in whatever day, date, year, month and all the rest of it you want, which is great because you can then adjust the time, the current time, using the control valve and function switch. So that's very exciting. Here we are, it's another day. The clock's been off all night, so I can now show you what happens when I first power it up, or when you first switch it back into normal operation come a morning. And the nice thing is that I've finally changed the sketch that drives the stepper motors so that they move together, which looks so nice. So that's good. The hands are both finding, this wouldn't normally happen, this is because I've just been disconnected. The hands are finding the calibration points. There we go. Look at that. It's 12 minutes, 13 minutes past 10. Isn't that lovely? Very pleased with that. I'll leave that running all day. I'm absolutely thrilled with it, to the extent where I'm actually sending myself to sleep at night currently, working out how I can make a huge one with bigger stepper motors, because I think it looks so nice. Also, I noticed that the real-time clock, which is obviously working perfectly because that's just been running off that little pen cell overnight, coin cell rather. I'm also trying to work out how I can make a huge one. Basically, I'm thinking about, because the difficulty is with this size, it's great because you can use, like I've talked about, a sort of standard, this happened to be from IKEA, but a standard clock face. If I wanted to make one for, say, a restaurant or a shop or something, I might want this to be 4 foot across, or let's make it simple, 3 foot 1 metre across. So I need to find something that looks like a clock enclosure but isn't. I'm vaguely thinking about dustbin or trash can lids, or some sort of moulded, injection moulded circular thing that I can possibly cut the front out of. Something will come to mind. It might be a table, for example, a circular table for a lounge. It's one of those things, I often do this, find myself doing this. There will be some mass-produced item that ticks all the boxes. I know it's out there, it's just whether I can actually get to my brain to discover it. So I will keep thinking. Thanks very much for watching. I hope this was of use to you. Hope to see you next time.